All right, Master Plan Part 3. There is a clear path to a fully sustainable Earth with abundance. In fact, you could support a civilization much bigger than Earth, than much more than the 8 billion humans. So we're going to walk through the calculations for how to create a sustainable energy civilization. The thing that is needed at very large scale that is not currently present is a vast amount of battery energy storage. Our rough calculations are that this is about 240 terawatt hours, or 240,000 gigawatt hours. That's a combination of electric vehicles and stationary storage. So we're assuming sort of an 8-to-1 ratio of stored energy to power.
And this is across mining, refining, battery factories, recycling, vehicle factories, all the things that we're going to talk about needing to invest in to build this sustainable energy economy.
In terms of wind and solar, how much land would be used? It's less than 0.2% of the land area of Earth. Anyway, the point is that with a really remarkably small amount of Earth's land area, we can go fully sustainable.
So this is the plan, and now we'll get into a little bit more of the details of the plan. Basically, 5 areas of work. First, renewable power the existing grid. Second, switch to electric vehicles. Third, switch homes, businesses, and industry heating to heat pumps. Fourth, high-temp heat delivery and storage for high-temp industrial and chemical processes, and a little bit of green hydrogen in there for chemical processes that need hydrogen. And finally, sustainably fuel planes and boats. So when we stack up all of these efforts, we end up with the numbers we shared at the beginning of the presentation. 30 terawatts, 240 terawatt hours, $10 trillion. And you may be saying, like, I need some context. Is this feasible? Spoiler alert, it's entirely feasible. Just looking at it from a growth rate perspective, how much do we need to grow the deployment of these technologies? We're talking about only a 3x growth rate in solar and wind deployment. When we look at the electric vehicles, they have to grow 11x. Well, they grew 60% year on year last year. And lastly, storage. Tesla's energy storage business has grown at 65% CAGR since 2016. The global energy storage business is accelerating pace as well. I mean, all these gaps are going to close, especially as this momentum of the transition to sustainable energy accelerates. And what about on the mineral extraction side? So this is a cartoon that sort of gives you a sense for all the ore and the extracted minerals that are coming out of the earth every year. It's about 68 gigatons. So each truck is a gigaton. What does this look like when we're in a sustainable energy economy? Looks like that. The resources are there to support the transition. This is cumulative demand to move in the sustainable energy economy direction until 2050 relative to USGS resources today. What people think happens is, oh, there's this many resources, next year there's going to be less because we're going to extract them. What actually happens is, as we extract resources, we find more. And you can see on the right what has actually occurred with the key materials to the sustainable energy economy. Since 2000, as the sustainable energy economy has been growing, and Tesla's been growing, and all the industries around us have been growing, the actual resource availability has increased, not decreased.
Earth can and will move to a sustainable energy economy, and will do so in your lifetime. Yeah, I mean, my personal opinion is that as we improve the energy density of batteries, you'll see all transportation go fully electric, with the exception of rockets. That's awkward.